Let's see what are forces, the definition of force. So if I say what is the definition of force, it goes like a force is a push or pull exerted by one object on another object. It could be push, it could be pull. The gravity pulls us towards itself. Or if I push it the object, it will go on that direction. That is the push. Push we exert, and pull also we exert. So it depends on the object and the situation. But gravitational force is an example of the object of the force which is pulling us towards itself. Okay. Now, in order to escape that pulling force, what we do? We exert pushing force. So, forces are vectors. Forces are defined as vectors. Why vectors? What is vector? First of all, we learned in the previous chapter. Vectors are has the units which has magnitude and direction. Okay, so now if I'm saying that force is a vector, so what does it mean? The force has a magnitude and direction. Now let's talk about an example like as I was talking about gravitational force, so let's talk about that. So gravity, does it have any magnitude? Yes, it has a magnitude. We learned that the force that gravitational that works due to gravity is m into g. So what is m? M is the mass on like any object on the earth on which the force is acting. Suppose I'm talking about this marker. So what is the mass of this marker? Say 10 gram. 10 gram. And g, what is the value of g? G is the acceleration due to gravity. So that is 9.8. So what is the force? What is the gravitational force acting on this specific marker is 9.8. Okay, this is force actually. So due to the gravitational force, of this object has a weight. We say mostly weight. Weight is the force acting on an object due to gravity. So this is the force acting on this object due to gravity, which we term as weight. So we say that the weight of an object, of this object, of 10 gram mass is 98 Newton. So this is how we define the force due to gravity. Now there could be other forces as well. Suppose F is equal to mass into acceleration. Now why is that? Suppose this is an object with a mass 10 gram, as I said. Now forget about the gravity. Say I am pushing it with a certain acceleration. I'm pushing this object with a certain force, and the object gets an acceleration due to the force applied. Okay, so the mass into the acceleration, multiply the acceleration that the body will have, is equal to the force I applied. So the mass of that object was 10 gram, and after I put a force, it moves with a certain acceleration. Suppose the acceleration is 2 meter per second square, and this is suppose gram. Okay, so if we square, we need to convert it into kilogram, 1000. Okay. Now this n into a will be equal to the force I applied. So what would be the value? The value would be 0, 0. 0.001 into 2 or 0.002 Newton. So this is the force which I applied on this body so that the body moves with an acceleration of 2 meter per second square. So this is how we can figure out the value of force exerted on a body. Now forces, okay, I say that forces are vectors. It has magnitude and direction. Okay. Now why is it magnitude? Because a force which is denoted by Newton has a direction. When I'm talking about the gravitational force pulls the object towards itself. So it has a direction in which, what is the direction? Direction towards the ground. So the gravitational force works on the downward direction. So it has a direction. And it also has a magnitude, the force at which obviously had a magnitude, because with a certain magnitude it is pulling towards it. So that's why we say that force is a vector, as it has both magnitude and the direction. Now, the symbol of force is defined by F, or the unit is defined by Newton. Okay, so in order to understand force in a more precise way, suppose I say you have to pull an object of 10 kgs. Okay, you have to pull an object of 10 kgs up to, suppose, 5 meter. 10 kg object up to 5 meter. So for this you have to apply some force on it, obviously. Now if I say that you have to pull an object of, you can easily do it, 10 kg, 5 meter, you can easily do it. Now if I say that you have to pull an object of 10 plus 10, 20 kg, now it will be a bit difficult. So why? Because the more the mass is, the more the force is. The more the mass is, the more the force is. Okay. So when the mass is increased, you need to apply more force on it in order to pull it. So this is the impact of mass on the force, and also acceleration also. Suppose when you are pulling a body of bigger mass of 20 kg, the acceleration in which you will be pulling would be less. Okay, but if I say 10 kg, then you can easily pull it with much more speed than what you had in the 20 kg time. So that means that the force, so the value of mass and acceleration depends on the force applied. We can also say that F is directly proportional to A. The more, so the more acceleration you need to apply more force. So this could be the examples, or this could be the basic understanding of forces. Next slide, we'll be talking about fundamentals of forces.